Hi everyone, welcome back. This is Steve Smith with the SPARQ Observatory, and I thought I'd put together a little video showing each of the steps, the images that are created by each step in the workflow that we have. And so here's our workflow, taking some images, then using PixInsight to work with the raw images and the calibrated ones, working with them until you get down to a single image for each filter, and then working on just the lumen, and then combining the color filters into one image and working on those, and then putting the lumen image with the color image, the RGB image, to make an LRGB, and finally cleaning stuff up a bit in Photoshop if needed. So not all these steps are necessary, especially as you get deeper into the process. You may find that some things work better than others. And in the image that I did of NGC 3628, I realized that I needed to put an additional step in the middle. And so I'm going to call that 16.5. That's SCNR. This is a PixInsight little program, and I have a little video on that. This is subtractive chromatic noise reduction. And so what I found is that the image kind of had a bit of a green tint to it. This is pretty normal for us at the SPARQ Observatory because we have some parking lot lights right next to the observatory. So using the green noise reduction in PixInsight really kind of takes care of that. So I did that after the color calibration. Other than that, let's go ahead and take a look at the images as we go through each step. Some of the changes will be very subtle, some will be more dramatic. And we're going to start, not at the very beginning, but the first image I'm going to show you is a raw image, auto-stretched in PixInsight with the calibration frames applied to it. So this is a lumen image, and this is in PixInsight, and it is auto-stretched, meaning this is not the actual data, but PixInsight allows you to stretch the contrast so that you can see what you're working on. So this is just one single lumen image, calibrated, with cosmetic correction, registration, star alignment. So we picked one lumen image to align all of our images to, regardless of filter. And this very often results in a lot of the images having black edges because we do dither between each image. So the center of the image is not always the same from image to image. And when we register them, we do get dark edges. That's very normal. Then we stack the images so that we end up with one master image for each color, for each filter. This is just the lumen master. And then we crop to kind of get rid of the bad edges that we have. Continuing to work just on the lumen, this is automatic background extraction. Trying to even out the background. It's still pretty cloudy and foggy, but better than the previous. Blur Exterminator, Russell Croman's great tool to combat the convolution, the diffraction that happens as the light comes through the atmosphere. A little bit of noise reduction, Russell Croman's Noise Exterminator to even out any noisy areas where the pixels right next to each other are very contrasty. And finally, histogram transformation. So this is where you go from an auto stretch, you set it back to the original data, and then you manually stretch the image to get what you want. And this is really where we squash down the noise in the background and bring out the stars and the galaxy. Then we go over and just work on our RGB image. And the first thing we need to do is combine it with narrowband. And I didn't use narrowband in this image of NGC 3628, so I don't have any image to show you for that. And then you combine all the masters together. And ours sometimes looks blue, sometimes looks green, but this is very common when you combine the different color channels together. And of course, immediately we want to deal with that, and we do that with automatic background extraction. And that gives us a much happier result. We still have a lot of stuff to deal with, but definitely doesn't look like this was going to be much of a problem to work through. Color calibration. This is using the Gaia satellite data to automatically calibrate all the color in the image. But this is where I realized we still have a bit of a green tint in the background, which is, again, from the lights in the parking lot next to the observatory. So I used the SENR tool, the subtractive chromatic noise reduction tool in PixInsight. And a lot of the green has disappeared, and there's still some there, but I was able to deal with it a little bit later on. Again, Russell Croman's Blur Exterminator to bring out some detail that is lost when light gets diffracted through the atmosphere. Noise reduction, Russell Croman's Noise Exterminator. And finally, histogram transformation, again, where you manually stretch the image yourself. All the other images, with the exception of the lumen histogram transformation image a few seconds ago, all the other images that we were looking at were auto-stretched in PixInsight, just the contrast that PixInsight sets up so that you can see what you're working with. But if it's auto-stretched, it's not the actual data until you get to the histogram transformation. That's the way you get your image kind of pulled out. And this is not auto-stretched, this is manually stretched. Then we put them all together and make our first LRGB image, put the lumen with the RGB master that we had. Little curves transformation to kind of bring out a little more contrast. Local histogram equalization. This is to check specific areas one at a time, larger areas in the image to see if we can adjust the histogram within each area instead of the whole image at once. And I do have a video on Dark Structure Enhance, and I used Dark Structure Enhance on this galaxy, and after applying it, I thought it was a little bit overkill in terms of bringing some things out, so I decided not to use it. But I do have the video on how to use that script in PixInsight. Last thing you would do is when you're done with your LRGB in PixInsight, you save it as a TIFF for Photoshop. Photoshop does not recognize the XISF file format from PixInsight. So TIFF image for Photoshop, and remember, it should be 16-bit, 32-bit, depending on your system, but ours is 16-bit. Now we're in Photoshop, and the first thing I do is go through the entire image and look for the odd pixel here and there that didn't quite that escaped all the calibration and cosmetic correction and other things that we did earlier. I didn't need to do a whole lot with the background sky here because it was already pretty good, but I did darken it very slightly and blur it a bit. High pass filter with a hide all mask to enhance detail in the dust lane in the galaxy. And then I used a little bit of blur. There was some artificial, what to me looked like a bit of an artificial line here and there on the outskirts of the galaxy, and also on the diffraction spikes on the bright stars. So I used the Gaussian blur tool feature in Photoshop to smooth those out. And then finally, the last thing is work with saturation and vibrance to bring out color in the image. So that's the workflow with each image, and so there's quite a bit of involved to get to this. And again, this is a very reasonable workflow. This is not a particularly long one, but it does get you to, I think, a pretty good image. Thanks again for watching. I do have videos on all these techniques in the SPARQ Observatory YouTube channel, so do check that out. Thanks again for watching, and I'll see you next time.